So this is from 4.5, which we covered last Friday. All right, so we're asking about what is the value C for this to be a perfect square trinomial. So perfect square trinomial, we have to take the middle one, B, divide by 2. Half of 10 is 5. Now, C is going to be that value squared. 5 squared is 25. Okay, rad. So we all got it right. Awesome. Mark this correct. Perfect. Let's go to the next one. So if I'm asking you what to be for perfect square, I'm sending it. I only send one at a time. All right, I'll do you a question. No? Okay. Here we go. This is being sent to you. Solve by completing the square. This was the crux. This was what we really wanted to get to last time. How do you complete the square? On the other side. Which part on the other side? I actually want to open this. Whoever's phone will you put on silent? Also, take this opportunity for free to put your phones over there, because I know people don't have their phone over there. This biggest. Last notes. Are we done? Yeah?
No, I'm not done.
Look at your notes.
Oh. No, I just wanted to make it.
We're gonna go over it together.
No. Yeah. No, I know.
Wait, is this the thing that adds up to -5 and multiplies to 4?
Yeah. No.
No, sorry. Multiplies to -5.
So, tricky trick, I picked something where you could actually factor, but how are you supposed to solve it? How are you supposed to solve it? Completing the square. You have to use the completing the square method. Have to use completing the square method. Okay. We have 0 people submitted. Come on. You just have to you have to actually find the 2 answers. Find the 2 answers.
Can you square root something in a square root?
I'll give you a hint. The 2 answers are integers, so I'm looking for 2 integer numbers. Okay. 2 integers.
Is it the square root of 3?
How did you get that?
Wait, was that right?
No, how did you get that?
I got x plus 2 equals the square root of 5 and subtract 2 on both sides.
What did you say? X squared plus.
Oh, so okay, I got it.
I got x squared. Oh, I had x squared plus 4x equals 5.
Okay.
Then I square rooted both sides.
Wait, I got it.
But you can't do that.
What?
Because you have x squared plus 2x. So then you'll literally have square root.
4x.
You'll have square root of x squared plus 2x equals square root of 5.
Plus or minus. I don't know how to do that.
No, I have x plus 2 equals square root.
How do you do plus or
No,
minus?
because you're adding. It's a binomial. You have to do the binomial first before you square root. Does that make sense what I'm saying to you?
Not really.
So this is, oh my gosh, hold on. So this is what you had. Yeah, I'm waiting for some people to submit.
How do you write 2 rads?
Okay, hold on. So this is Jesse's question. He wants to square root both sides.
Yeah.
But then why is this not right?
It's not. No.
It's not. It's not because these are being added.
It's 5 plus 4.
What?
$55.
Right, we're not done. So I'm answering a question for Jesse. Okay, so I'm answering Jesse's question of why we can't just square root both sides. Do we have a good reason why we can't do this?
Because they're being added.
Because they're being added. I can't just willy-nilly square root and have this be x.
So if it was 4x squared, then I could.
If this was 4x squared, you can square root it and it'd be 2x.
So then how do I get out of where
So completing the square. First step. So ready? I'm gonna go over it. Here we go.
Wait.
I'm waiting for people to look at the board. This is one of the questions on your test. There's 20 questions on your test. This is one of them. Literally, solve by completing the square. You have to know how to do this. This is why I'm taking time today to review it. So, I have x squared plus 4x. And the first thing I have to do is move the 5 to the other side. So, I'm going to add 5 on both sides. That way it moves together, right? Because this is minus 5 if I add 5 on both sides.
Yeah.
Right? It moves over. Okay. I just want to save some space for myself. Okay. Ideally, I would like to write the left side as a perfect square trinomial. So what number is half of 4? 2. Okay. And then square that number. 4. So I must add 4 on both sides. Now that I've done that, I can write the left side as x plus 2 squared, because it's a perfect square trinomial. The two factors would be x plus 2 times x plus 2. Awesome. Okay. So the right side is equal to 9. I need to get x by itself. Now I can square root both sides. Okay. So the square and the square root cancel out, and I have x plus 2 is equal to plus or minus 3. Since we, what? We're not done. We're not done at all. You can find 2 integer answers, literally. So if you subtract 2 here, you can have x is equal to negative 2 plus 3. What's that equal to? 1. You can have x is equal to negative 2 minus 3, and that is negative 5. Okay. What? What's wrong?
I thought you could write it like.
You could write it as negative 2 plus or minus 3, but this is actually stuff you can do. Like, you know what 2 minus 3 is. You know what 2 plus, you know? Like, this is, I picked nice integer numbers for you guys.
If we didn't do it all the way through,
So x is negative.
If this was like 8 over here instead, then you could leave it as radical. But, right, but I gave you a nice integer number. So what I'm expecting in the answer is literally, come on. X, oh my gosh, come on. Oh, I have to go over here. So what I'm looking for is x equals 1 comma negative 5. Like, that's what you could put.
Oh, I just did x equals 1 and then call it x equals.
And you could, okay, so you could do x equals negative 5.
So
That's fine. Or you could do enter x equals negative 5. That's fine. All of these work. All of that works. All right. Questions. Let's see. Okay. So ideally we need, okay, so this top one, x has to be by itself. So you're not done, right? This one is right. This one's right. This one only has one of the answers. This is actually, well, that's a coordinate, so I don't want to do that one. This one's right. This is right. That's fine. This is, oh, actually it's supposed to be 1 and negative 5. So this is right. Okay, so overall pretty well. Okay, so I'm gonna stop the poll. If you want, you can like put your hats away, whatever, who cares? Okay, so what's wrong? You can put your hats away, but you don't have to. It's just preemptively saying it because I know someone's gonna immediately ask if they can put it away. Quadratic formula. So the quadratic formula is your nuclear option. You have no other way to solve your problem. That's when you use the quadratic formula.
I can't wait.
So I will give this to you on your test. I will write this part that is boxed. I'm not going to say quadratic formula, blah, blah, blah. I'm just going to put what's in the box. So you have to recognize that's a quadratic formula, but we actually haven't covered that many. Thank you.
You're welcome.
It's my pleasure.
Okay. So this is the nuclear option. Let's review a little bit. Yes, the nuclear. This is like worst case. This is what you go to. Well, if you're going to war, you don't automatically go to nuclear war. First, you try to be nice. You try to make a little treaty. Factor out the greatest common factor. Then see, is this a special case? Can I like be like the kings and queens of Europe? Can I like, marry in, try to solve this problem with special cases? Difference of squares, perfect square trinomial. And then you're like, okay, now none of those have worked. So then I go through and see, can I factor it? And if nothing else works, then you nuke them. Then you do quadratic formula. But only if you've tried everything else first. I've said this multiple times. If you go straight to quadratic formula for every problem, you will not have enough time to finish the test. You won't. Huh?
It's so easy.
This one?
Say the steps again.
Yeah.
And write it down.
So first, you try to factor out greatest common factor. Factor out greatest common factor. This is also listed, I think, on page 29. Is that? Yeah. It's literally page 29, I think.
Can you just write it out? Factor of greatest common factor.
I'm writing it out for you, don't worry, but I'm showing you I already wrote it for you secretly. Right here, page 21. Approaches to factoring trinomials. Here's the steps. First, greatest common factor. Then, see if you have a special case. Is it a perfect square trinomial? Is it a difference of squares? Then, only then, that you've already checked those first two, can you actually just factor it using, the X method, what adds to the middle, multiplies to the last, and then, only then, very last option, nothing else has worked. We're down to our last option. That's when you use quadratic formula.
Which would be number 3.
Which would be number 4. It's not even listed on here. Okay, go back. So, factor out greatest common factor. Then you look for a special. So this is special is difference of squares. Or perfect square trinomial. Perfect square trinomial, then you'll try factoring like normal, and then this is where you use quadratic formula, is the last case. So, quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. Okay, why? There's many reasons why this is the last case. It takes the longest. There's many places for you to mess up. Many places. What if you don't have everything under the square root? What if you forget the negative here? What if you accidentally multiply in the wrong order? If you plug it into your calculator wrong, like you have to do order of operations. What if you divide by 2 and then multiply the whole thing by a, right? So what if you're like dividing by 2 and then multiplying by a, right? Dividing this whole thing by 2 and then multiplying by a. Do you know what I'm talking about when you enter in your calculator? Yes?
Are you going to give us the formula in the test?
Yes, I give you this formula. I'm not going to tell you that it is quadratic formula, but I'm going to give you this part that is boxed.
Did we get like the negative b?
Did I give it to you for your quiz?
Yes.
I did. Did I give you vertex form for your quiz?
Yes.
Yes. So you'll get that as well. Okay. So there's many places for you to easily make a little mistake. What if you don't square it in the right place? What if your square root doesn't actually cover all of this? And you have to show enough work, and it's a time suck. So there's many reasons why this is the last case. Okay, so are we ready? I'm going to explain how we're going to solve this example. Example 1, solve each equation using quadratic formula. But before we do that, let's go in order and see the preferred way of solving. So my goal for this exercise is to prove to you why quadratic is like the last option we want.
So are you gonna
What?
I was gonna say, are you gonna get I was just gonna ask, are you gonna give a quadratic one, knowing that we're not be forced to do anything quadratic one?
So just like the practice test, there's 3 questions where I specify how you must solve it. One of them is solved by completing the square, one of them is solved using quadratic formula, and one of them is solved by factoring. And I tell you that's like how I want you to solve it. Meaning, if you take the one that you're supposed to solve using difference of square, or using completing the square, and you don't solve it that way, you don't get the points, because I'm testing you on the method. Solve each. Okay, so let's go through our steps. See the preferred way of solving it. So, is there a greatest common factor I can pull out? No. Okay, normally this takes about 1 second. It's fine. We'll speed up. No greatest common factor. Is this a difference of squares? No. Is this a perfect square trinomial? No. How do you know? How do you know it's not difference of squares? Done? Done? Why is this not difference of squares?
I know it, but I don't know how to explain it.
Difference of squares only has 2 terms, and there's 1 subtraction. Okay, why is this not a perfect square trinomial, Cooper?
Because there is no perfect square in there.
Because 7 divided by 2 is 3.5. 3.5 squared is not 6. Okay, cool. It's not. Top of page 40. All right, so no greatest common factor. It's not a special case. Let's try factoring. Do you know numbers that add to 7, multiply to 6? Add to 7, multiply to 6. 6 and 1. So I can factor, say, x plus 1 times x plus 6 equals 0. And we're solving, meaning we have to set each factor equal to 0 and get x by itself. So x plus 1 equals 0, subtract 1 on both sides, x equals -1. X plus 6 equals 0, subtract 6 on both sides, x equals -6. Did we solve the problem?
Yep.
Yes. Done. Look how much work that took.
Yeah, but you didn't use the quadratic.
You're saying that
I was saying D-O-N-E. D-O-N-E.
Called you out real quick.
Done. You're like, what? So, if this was like solve any way you want, look how short this is and how quick it was. Normally, you would be like, when you're focused, it's not end of day, you'd be like, oh, it's not, no greatest common factor, not a special case, let's factor and we're done.
Where is that?
If you add 1 plus 6, it's 7. You multiply 1 and 6, it's 6. Yes.
Oh, we did this on the
You just
What?
the answer sheet.
Missing the point.
I know, but like just in this, no, this one doesn't say.
So I said, hey guys, let me be very clear at the directions for this example. So while we're going to go through my point of this example. Okay, ready? Everyone look up. Ready? Put your hands like this, right? So we're not touching anything. We're focusing, right? Because we're not fidgeting. Hands up. I want to see everyone's hands. Come on. Let's go. Come on. I'm waiting for you. Okay, so ready? We're focusing. So the point of this example is we're going through and showing which would be the preferred way of solving. And the point, Felix, turn around. Showing you why this problem, it's better to factor than quadratic. So we're practicing using quadratic, but really my goal is to show you why is this the nuclear option. We're going to go through right now, and we're going to do the quadratic formula. And it's going to take the rest of the space allotted for part A. And it's going to show you how much time it took, how it overcomplicates it. And only if we have no other option do we use quadratic. If this was in the part of your test that says solve using any method, this would be the preferred method. I'm not going to give you a nice problem like this for the quadratic. When I'm saying you must solve using quadratic, it's going to be a bad problem. Okay. So, the goal of this example, show you which one do we do. Okay. Now, let's go through using, thank you for putting your hands up. Now we can write because we focus. We all heard this message. Now let's use quadratic formula. So keep in mind, quadratic formula only, it has to be in standard quadratic form. ax squared plus bx plus c. What is my a here? 1. B is 7. C is 6. Okay, so let's go through and let's write it. So x equals -b plus or minus square root of b squared minus 4 times a times c all over 2 times a. If this is all you wrote on your paper and then you wrote those numbers, I would like a little more work because I've taught you how to find the zeros using a graph. You could have just, I don't know, I'm wanting a little more work, maybe one more step or something. Okay, so -7 plus or minus square root 49 minus 24. Yeah, but the issue is if you miss any little addition or don't have everything with the right parentheses, it's not going to give you the right answer. Right, you have to have the right number of parentheses.
Yeah.
Yeah.
Like everything plug in the same and that you would write on your paper and plugging it in.
The thing is, okay, if I gave you an A that was not 1, you know how you have to do 2, let's say A here was 3, you'd have to do 2 times 3 on the bottom. And
Yes.
what some people would do when they write it in, instead of saying all of this divide by 2 times 3. Well, the calculator reads from left to right. It would divide everything by 2 and then multiply everything by 3 instead of dividing by 2 times 3. It's just the order of operations. And I mean, this is my 5th year teaching. And when I say people mess up things on the calculator, like, yeah. Unfortunately, I know at least one person in this section is going to do this. Because that's just that's just what's been happening. Last year it was much more. No, we're not calling out anyone. It's just, I'm telling you, you have to be meticulous when you're entering in on your calculator. Because this is a common mistake people make. Okay.
So can we just plug in like separately, like order of operations? Like...
So that's what I'm showing you right now is literally the order of operations.
Okay.
-7 plus or minus 5 over 2.
That's fine.
No? Can you simplify this? You can simplify.
Obviously.
So you can have x equals -7 plus 5 over 2, which is -2 over 2, which is -1. Okay, it matches the first thing we found. You can have x is equal to -7 minus 5 over 2, so that's -12 over 2, so that's -6.
No way it matches. That's 8 times.
Right. Yeah. So it's longer. We use the quadratic formula. We know we got the right answer. It's just longer. And if you don't show like all of this stuff and you plug into your calculator wrong and you get not the correct answers, you'll get very small credit. Like the more work you show, the more credit you get. And the quadratic equation has a lot of work to show.
So you get more points for using quadratic formula?
What?
You get more points using quadratic formula?
More points. Not if I gave you A in the portion that's solved using any way. It's worth like 2 points because it's super like chill. But then you spent all your time doing quadratic equation for it when it's not actually like a hard level problem. Right. So that's what I mean when you say you'd suck your time for some of the easier questions you could solve better other ways.
So like there's gonna be like one question.
There'll be at least one, maybe like 2. Be like 2, maybe. I don't know, look at your practice test. I gave you guys a practice test. Solutions are online. No. Okay, ready? Let's go through. Is there Grace common factoring? Pull out. No.
No.
Is this a difference of squares? No. Perfect square trinomial?
No.
No. Can I factor this?
Difference of squares?
Sure.
So a difference of squares is literally x squared minus like 4. Difference, subtraction of squares, 2 things are perfect squares.
So it's just 2 things?
Huh?
So it's a
2 terms. Yeah, it's a binomial.
Oh. So for that one, that wasn't right.
You subtract that.
So if this was the portion, right, A. If A was the question where it's solve using any method, you could use a quadratic equation, but just know the points per question deal with how hard they are. And since A was not a hard question, I mean, using quadratic is a lot of work for not many points.
Oh, okay.
You only have to use one to solve.
Okay. I was just asking because on the test you're
She's
going to
asking the same
specify.
question that I asked her.
Which
I'm
is,
still a little confused about that.
Are you still gonna are you gonna be allowed to
Like for A, if we just did factoring, that would have been right.
yes.
But for this one,
Okay, I just,
would that?
like there's gonna be questions where it's like use whatever formula you want, and there's gonna be others
Or
where
is
it's
it
like
just use quadratic?
right.
Where it says use quadratic.
Okay.
So if you look at your practice test, same layout, change some problems, change some numbers, yes. Sure. Grace common factor? No. Difference of squares? No. Perfect square trinomial?
No.
No. Can we factor? Do we know 2 numbers that add to 11 multiply -12?
Yeah.
What?
11 and 1.
So
Negative.
Negative 1
Negative
and
1
12.
11.
t -1 times t plus 12. Okay. Add
Okay,
12 plus -1 is 11. 12 times -1 is -12. Okay. Okay, so we factored, and then you set each factor equal to 0. All right, so we see t equals 1, and I'm literally showing every step of work with my factoring. Oh my gosh.
I hate when it's probably T.
So this is a relatively like short problem. So a problem, I'm expecting you, if I'd give you a problem like this, I'd expect you to solve it this way, and you'd be done. Move on. End of question. But this example is to really prove to you why you only use quadratic if it's like, look, like that's it. We have to use it. Because now we're about to do quadratic, just a little practice, and it's going to be long. Why? This is supposed to be a 2-point easy problem, right? It's not the one where it's like 5 points, and it's going to be difficult. You have to use quadratic, right? I try to make each problem like the level of difficulty worth how many points, and that means, oh, you show partial credit, you'll get like most of the points for the hard problem. Okay. I don't know. Trying to give you the best grade I can do. All right, let's go. What is my A value here? Yeah, remember you used to fight me about work? Whatever. Okay.
I did something last year. I used to not know my work and still get it. This year I'm getting it wrong.
Well, that was already.
Yep.
So
It's okay, so we pulled out A is 1, B is 11, C is negative 12. So now I gotta put in the quadratic equation. X equals negative B plus or minus B squared minus 4 times A times C 2 times A. What is negative 4 times negative 12?
48.
48. Okay, so I have 121 plus 48 all over 2. So unlike when I was showing you in the green, right, the nice, easy factoring, I'm like skipping major steps and still showing tons of work. Because 11 squared is 121. Negative 4 times negative 12, 48. Still skipping lots of steps, and it's a lot of work. Negative 11 plus or minus square root 169 over 2. What's the square root of 169? 13. So, negative 11 plus or minus 13 over 2. Negative 11 plus 13 is 2 over 2, so that's 1. Cool, so we got the first answer. Negative 11 minus 13 over 2, negative 24 over 2, so that's negative 12.
So I did get it right. Sorry, I just wrote it.
What's wrong?
I'm nothing. I'm just confusing myself.
Felix, maybe you okay?
I'll go first.
Yeah. All right, are we good with this one? Can we keep going?
Yeah.
Yay, okay. So let's go to C. It is 304. 304.
Am I right?
No.
So, is there a common factor I can pull out?
No.
No, what? This is the
I
one.
take that back.
No common factor. Is this a difference of squares?
No.
No. Perfect square trinomial?
No.
No. Can I factor what two things? Add to 10, multiply 12.
Yeah.
1 and 12, no, that's 13. 2 and 6, that's 8. 3 and 4, 7.
No, nothing does.
Nothing. This is the time where we must use quadratic.
Quadratic formula.
Yeah.
Miss Cole made it bad.
Yeah, Miss
No, yeah, no. I don't want to hear about other teachers. Goodbye. Shh. What?
Can you sing a song?
No, because my.
You want to sing it? Okay, ready?
Square root of 4 minus 4 AC all over 2a.
I've never heard
X
that.
equals negative B
Plus or minus the square root
Yes!
of minus 4ac all over 2a.
So she's saying that on the final.
What is this?
Cool.
It's a way to remember it. I've never heard it.
Welcome.
Sing
Welcome.
Yeah, sing it with me. Equals negative
Yeah, sing again.
B squared minus 4AC.
All over 2a.
That's so fun. Do you join in?
Now we got it.
Super. Well, I mean, I'm glad you know it, but I'm gonna give it to you anyway.
Wait, are we recording?
Yeah. Yeah, because people are gone, so I make the screencast so people watch it.
Now they'll learn it. They're gonna hear us.
Wait, Did they get that? Wait, like our screencast right now?
Yeah.
I don't want
Wait, the screencasts are available to everybody.
Oh my god.
I uploaded it to my YouTube and posted it on my jag.
On YouTube?
Huh?
Bro, you should know this
Do you
already.
post other things on your YouTube channel?
No.
She posts DIYs.
Hey guys, what's up, Brian?
Satisfying videos, bro.
Okay. Tickety talk. Tickety talk. Tickety talk.
Dude, what do you mean? She
Let's
streams
go.
porn, bro.
Tickety talk. Let's go. So, we realize we have to use. Stop talking. Stop talking. Stop talking. Okay. Sit down. We went through, and there was no other way to solve it. We have to use quadratic formula. We have to use quadratic formula, right? There's no common factor, no special case. We can't actually factor, so negative b plus or minus b squared minus 4 times a times c. Yeah, well, imagine you doing it on a test and like your stress, anxiety, it's going to take you a long time. You're like, oh my god, did I plug in the right one? Oh my gosh, is it positive, is it negative? I'm trying to make it simple for you. I know you guys are going to freak out when you go on the test, so do the easy way. We missed it. No. No. Shh. No, we're focusing. We're focusing. We're trying to be as efficient as possible.
I'm lost after I got to 52.
Negative 10, let's see, plus or minus. So this is 100 minus 48 all over 2. So this is negative 10 plus or minus square root of 52 all over 2. Okay. Have you guys ever played the game 52 card pickup?
Yes.
So a deck of cards.
I hate that.
A deck.
We should play with the D. We should have a D player. Yeah,
Not-
do you play?
No. Okay. You're missing the point. I try to give an example and I'm gonna have to like re-explain it. Okay, 52 card pickup is a regular deck of cards, right? Card deck has 52 cards. How many suits does a card deck have? 4. So wait, how many cards are in each suit? How many cards are in each suit? So there's, ace, diamond. How many different diamond cards are there?
What's 52?
That's exactly what I'm trying to ask you. Secretly, what is 52 divided by 4? What is it?
Oh my god, you're a genius.
I do that.
13.
I put it in simple terms though. That's
There's
not me.
13.
13. I put it in
I'm
simple
like,
terms.
oh, secretly you know what 4 times 13 is. So instead of saying square root of 52, I could say
4 rod 13.
root 4 times root 13, which is 2 root 13.
I would not do that.
Yeah, I would not do that either.
I know, which means you wouldn't actually fully simplify it, which is an issue. Okay, so negative 10 plus or minus 2 root 13 all over 2. So I can rewrite this as, I'm not asking, I'm pausing because there's noise.
Can you cancel out the 2?
I am doing that.
Pausing because you, bro. Sorry,
Okay, so what I can do is I see there's a factor of 2 everywhere. So I'm going to rewrite this as negative 10 over 2 plus or minus 2 root 13 over 2. And then, oh my gosh, guess what? Some of these cancel out. So it's negative 5 plus or minus root 13. And this is an acceptable answer. Because I have a root, I can't simplify. Unlike the first problem we did today, where we're plus or minusing an integer, you can do integer addition and division. That was pre-algebra. But I'm not expecting you to add root 13. No, that's like 3 point something. Who cares? I want it to be exact, so I'm adding plus or minus root 13. And yes, what this means is negative 5 plus root 13, negative 5 minus root 13. That's secretly what the plus or minus means. 2 answers.
Plus or minus.
Okay, now let's try the next one. Hold on. Do I want to try the next one, or do I want to do?
I agree with Jacob on this
Yeah. I want to do this one. I want to do this one. Okay. So D is where 4.4 is going to come to play. Remember how we were talking about imaginary numbers? What if I had an imaginary number under my square root? What if I had a negative number under my square root? It'd be I. Right? So I could rewrite it in terms of I. So I'm going to rewrite this guy as 3v squared plus 5v plus 11 equals 0. Guys, we got to get through this problem.
Yeah, boy.
So if I would move this forward, so first off, 3, 5, and 11 have no greatest common factor. This is not a difference of squares because there's more than 2 terms. I need to see, is this a perfect square trinomial? No, because the middle number is 5. Half of 5, I mean, half of 5 is a decimal. So I got to try to factor it. So if I move the 3 and multiply by 11, do you know any 2 numbers that multiply 33 add to 11? Multiply to 33, add to 11. Okay, so 1, add to 5. Multiply 33, add to 5. So 1 and 33 doesn't add to 5. 3 and 11 add to 14, not 5. And that's it. So we must use quadratic formula. Yeah, there's no other option.
This is to prove.
This is I'm sorry, pause. What is this lesson called? Oh.
No, I know.
No, but also wasn't.
Come on.
So we're so
A equals 3,
going over this verse with the
B equals 5, C equals 11. I am trying to literally give you 100 on your test. I'm trying to give you 100 on your test. Come on.
We would never get this in public school.
False.
Really?
You would get this at the public school,
went to public school.
but half the people in here who are troublemakers would not be in the class. They'd be kicked out immediately.
It's true.
Wait, repeat what you just
Hey,
said.
but they also won't be as nice as you, Miss O'Brien.
I did not know
It's don't do this. Let's see. Negative B is 5 plus. Guys, I just want to finish this problem. Come on, let's just finish. Square root B squared is 5 squared minus 4 times A times C all over 2 times A. I'm putting parentheses around what I'm like plugging in. Because imagine if I had a negative number,
Sure. Okay.
right? If I had a B that was negative, squaring B would make it positive. So I put parentheses around what I put in so I don't miss negatives. I feel like, so you paying attention? I need you to write this down, okay? All right, let's simplify a little bit. So I have negative 5 plus or minus 25. Okay, what is negative 4 times 3? Negative 12. What is negative 12 times 11?
Negative 121. No, negative, I don't know.
Negative 132. Okay. But wait, 25 minus 132 is going to give me a negative number. Negative 5 plus or minus, let's see, 107?
Yeah, negative 1.
Root negative 107 over 6.
That is not a root. We can't square that.
So this is where 4.4 imaginary numbers come into play. So I could rewrite this as negative 5 plus or minus I root 107. Notice what happens to the negative under the radical? Disappeared because I rewrote it in terms of I. So there's 2 solutions. This is how I would write the solution. They both are imaginary. So what are the x-intercepts? How many x-intercepts does this equation have? None. No x-intercepts because both of the roots are imaginary. Both of the roots are imaginary, which means it doesn't actually touch the x-axis. It literally is a u. Do you see where my hand is? This is the x-axis. Ready? What I'm going to trace out for you is this graph. It doesn't touch the x-axis. So this is where it comes from. Every quadratic has 2 solutions. If you have an imaginary solution, you have 2 imaginary solutions, it literally doesn't touch the x-axis. This is why we had to deal with imaginary, is to discuss what if I use a quadratic equation, I have a negative under my radical. Okay, so this is where we'll stop today, but before you pack up, I want to make things clear. So tomorrow, you need to bring your practice test. You need to bring homework, maybe your book. The whole class tomorrow is you working on homework or Alex or your practice test. You could knock out almost all your homework before Thanksgiving break.
I'm already done.
And then we come back from Thanksgiving, we review for one day, and then you take your test.